Welcome to Daily Papers.
Okay, I have a question for you. When was the last time you navigated somewhere new without using GPS on your phone?
Wow, honestly, I can't remember. Maybe years ago? I just type in the address and my phone tells me where to go.
Exactly, and we do this with everything. We let algorithms recommend our next movie, we let AI help us write an email, we let autocorrect fix our spelling. It's incredibly useful, but what if there's a hidden cost?
That's the central question of a fascinating paper from researchers at the University of Central Florida titled The Silent Cost of Artificial Intelligence Assistance. It argues that every time we accept help from an AI, we're part of a tiny, almost invisible transaction.
And in that transaction, we're trading away a little piece of our own autonomy, our ability to think and act for ourselves. The paper calls this autonomy surrender. It's not a one-time thing, but a slow, gradual process that happens without us even noticing.
Right. You don't think, I am now surrendering my innate sense of direction when you use Google Maps. You just want to find the restaurant. But the paper points to some really stark evidence. Studies show that people who rely heavily on GPS have measurably poorer spatial memory.
And on the flip side, there's the famous example of London taxi drivers. Before the age of GPS, they had to memorize thousands of streets to pass a test called the knowledge. Brain scans showed that the part of their brain related to spatial memory, the hippocampus, was significantly larger than in the average person. It's a classic case of use it or lose it.
The authors call this process cognitive offloading, essentially outsourcing our thinking. And sure, we've done this for centuries. A calculator offloads arithmetic, but the paper argues that today's AI is fundamentally different.
It's different for three key reasons. First, the scope. A calculator only does math. Modern AI can help with reasoning, judgment, and even creativity, the core functions of our thinking. Second, the incentive. A calculator isn't designed to keep you using it for as long as possible. AI systems often are, with their frictionless, zero-effort interfaces.
And third, and this one is really mind-bending, is the asymmetry. Your calculator doesn't learn about you every time you use it, but a personalized AI does. It refines its model of you, getting better and better at predicting what you want, while your ability to make that choice for yourself slowly weakens.
To understand how this happens, the paper introduces a concept called cognitive bandwidth. Think of it like your brain's daily battery for decision-making and active thinking.
When an AI is constantly feeding you information, recommendations, and solutions, your brain gets overwhelmed. It's just easier to stop evaluating everything and start passively accepting it. Your cognitive bandwidth gets depleted. You switch from being a decider to just a receiver.
And if you do this for long enough, you approach what the paper calls the surrender threshold. This is the tipping point. It's the moment where we've relied on the AI for so long that our own mental muscles have atrophied.
And crossing that threshold isn't just about being a bit rusty. The paper says it becomes psychologically and cognitively difficult to take back control. We feel anxious making decisions on our own, we're less confident, and we're reluctant to turn the AI off.
That sounds pretty bleak. So are we all doomed to become passive blobs of human receivers?
Well, the researchers don't think so. They propose a solution, and it's a really elegant idea. They say we need to design AI systems with a built-in recovery mechanism.
A recovery mechanism isn't just an off switch or an emergency stop. It's a dedicated feature designed to help us restore our cognitive bandwidth. The paper describes it as creating a period of cognitive quiet.
It's a fantastic phrase. The AI would, at the user's request, stop providing information, creating a quiet space for the human to think for themselves, process the situation, and re-engage their own judgment.
The paper gives a great practical example. Imagine a diagnostic AI for doctors. Instead of the AI just spitting out a diagnosis for the doctor to approve, a system with a recovery mechanism would work differently. First, it would require the clinician to commit to their own preliminary diagnosis.
Only after the doctor has done their own thinking and made their own judgment does the AI reveal its findings. The interaction is no longer about passively accepting an answer. It becomes a structured comparison. It forces the doctor to exercise their own skills every single time.
It transforms the AI from a crutch into a tool for refinement. But this brings up another, even more complicated question. What happens if people don't want to recover their autonomy?
This is maybe the most startling part of the paper. It describes a potential end state called preference inversion.
Preference inversion is when we've become so functionally dependent on AI that we no longer see it as a loss or a deficit. We actually experience it as a preference. We like the convenience. We don't miss the skills we've lost because we've forgotten we ever had them.
It's the moment when someone says, "Why would I ever want to learn to navigate for myself? My phone does it perfectly." At that point, the paper argues restoring human agency is no longer just a design problem for engineers. It becomes a cultural and political challenge.
So the big takeaway here isn't that AI is bad, but that we need to be conscious of this silent transaction. We're getting amazing tools that make our lives easier, but we're giving something up in return.
Exactly. The paper makes the case that human autonomy is a resource, something that can be depleted but also restored. It argues we have an obligation to design AI systems that don't just give us answers, but that also preserve the conditions for us to find answers on our own. It's about designing for the quiet that makes our own thinking possible.